Good afternoon, students. Yeah, so already we have started the lesson light, and I have shared few videos also to you. So let us start with the previous video itself. Okay, so from that we will start.
Hello dear children, how are you? I hope you all are in the best of your health. Children, welcome you all in the science class by letter I. Because light of rays works under two.
So once again I will start with the laws of reflection. Okay, and then the next video I will show you. So let us revise this one, laws of reflection. Students, listen carefully.
Laws. Draw a line at perpendicular to the surface at the point of incidence. It is called the normal. The angle which the incidence ray makes with the normal at the point of incidence is called the angle of incidence. It is represented by letter I. The angle between the reflected ray and normal at the point of incidence is called angle of reflection. It is represented by letter R. Now, let's learn laws of reflection. First law of reflection says that the angle of incidence is always equal to the angle of reflection. That is why when a ray strikes any surface at angle I, it always moves to a direction which has angle of reflection angle R equal to angle I. If we change angle I, then direction of reflected ray also changes to make angle R equals to angle I. According to second law of reflection, the incident ray, the normal of incidence and the reflected ray all lie in the same plane. That is why we can show reflection in our notebooks, because all rays have same plane. Now think children, if reflected ray was in upward direction, would we be able to see that ray? In that case, the diagram of reflection would have been like this, where incident ray and normal would have present on the same plane, but plane of reflected ray would have been different. But this is not possible. Now, let us understand laws of reflection with the help of an activity. Fix a white sheet of paper on a drawing board or a table. Take a comb perpendicular to the sheet of paper. Throw light from torch through the opening of the comb from one side. Place a strip of plain mirror in the path of the light ray. What do you observe? Yes, we can see that the ray of light is reflected in another direction. Mark them as shown and also draw the normal. Now recognize angle of incidence and angle of reflection and mark them on paper. Measure these angles by using a protractor. You will find that both the angles are equal in measurement. It proves the first law of reflection, that is, angle of incidence is always equal to angle of reflection. Children, you can take different readings by changing the position of torch. sheet of paper represents one plane on the table. If we cut and bend the paper as shown here, we create a different plane. Now we can only see incident ray and the normal because they are present on same plane, and because of change of plane we are not able to see the reflected ray. This proves the second law of reflection, that is, the incident ray, the normal at the point of incidence, and the reflected ray all lie in the same plane. Dear children, now let's learn about regular and diffused reflection. Children, we know the reflection occurs when light rays falls on any surface. If reflection occurs from a smooth surface like that of a mirror, it is called regular reflection. For example, reflection from surface of water or from the surface of a shining tile. Reflection. Now let's learn about multiple images. Take two plain mirrors, hinge them with the help of adhesive tape so that they can move easily at different angles. Now set them at an angle as shown. Place any object like a candle, ball or a coin between the mirrors. We can see the image of the object in mirrors. Now change the angle of the mirror. You can see that as we change the angle between the mirrors, number of images formed in mirror also changes. So, dear children, can you guess the reason for the formation of these images? Children, these images are formed due to reflection of the reflected light. Daily life application of this is being seen at hair salon.
Yes, students, so many examples you have seen in reflection of light, that is multiple images they are formed. Okay, so the next one, how to prepare the kaleidoscope. Kaleidoscope is also based on the mechanism of working of the reflection of images. Okay, multiple images are
should fall on any white plain wall. You can see different colors in reflected light. This phenomenon of splitting of white light into its component colors is called dispersion of light. When you peep through the hole, you see sunlight. Children, you must have seen a rainbow in the sky just after a shower of rain. Do you know rainbow is formed due to dispersion of light? Let's understand this dispersion of light with the help of an activity. Take a bowl filled with water and place a plain mirror perpendicularly in the ball. Now place this arrangement near a window so that sunlight directly falls on the mirror. Place the bowl in such a way so that reflected light from the mirror should fall on any white plain wall. You can see different colors in reflected light. This phenomenon of splitting of white light into its component colors is called dispersion of light. So children, rainbow is a natural event which shows dispersion of light. Now let's learn about very important sense organ of our body, that is our eyes. Children, we have learnt that we can see things due to reflection of light. Now let's see what happens when these reflected rays enter our eyes. Our eye has a roughly spherical shape. The outer coat of the eye is white and transparent, which is called cornea. Transparent means light rays enters in our eyes through this layer. It is a tough layer. It protects the interior of the eye from accidents. Behind the cornea is a dark muscular structure called iris. The iris is that part of eye which give it its distinctive color. When we say that a person has blue eyes, we refer actually to the color of the iris. The iris controls the amount of light entering into the eye. In the iris, there is a small opening called the pupil. If we throw light in eye with a torch, the size of pupil decreases because eye cannot tolerate such a high intensity of light. If the light is dim, the pupil expands in order to allow more light to enter the eye. Light rays from the pupil falls on the lens of the eye. The lens present in our eye is convex lens, which is thicker at the center. The lens focuses light on the back of the eye on a layer called retina. The retina contains several nerve cells. There are two kinds of cells: cones, which are sensitive to bright light, and rods, which are sensitive to dim light. Sensations felt by the nerve cells are then transmitted to the brain through the optic nerve. At the junction of the optic nerve and the retina, there is a point called blind spot. It is a point where when light rays falls, we can't see anything. Children, let's understand blind spot with the help of an activity. Make a round mark and a cross on a sheet of paper at some distance. Hold the sheet of paper at an arm's length from the eye. Now close your left eye. Look continuously at the cross. Move the sheet slowly towards you, keeping your eye on the cross. What do you find? Round mark disappear at some point. Now close your right eye, look at the round mark and repeat the activity. What happens now? Yes, this time cross disappears. Children, the disappearance of cross or the round mark shows that there is a point on the retina which cannot send messages to brain when light falls on it. This point is present at the junction of the optic nerve and the retina. There are no sensory cells, so no vision is possible at that point. That is why we are not able to see the cross or the dot from that distances from where the light rays coming from them focused on blind spot. Children, one more interesting aspect of our eye is that the impression of an image does not vanish immediately from the retina. It persists there for about 1/16th of a second. Look here, we have some pictures with very little difference. Observe these pictures as one image per second. It seems like this. Now, let's see them by increasing the rate 5 images per second. Can you observe any changes? Our eyes can see changing images. Now, if we change the rate at 24 images per second, oh, it's looking like a video. At movies, this quality of our eyes is used. So, dear children, eyes are very important for us. It is necessary that you take proper care of your eyes. Let's look at some important points for care of our eyes. Do not rub your eyes. Wash your eyes frequently with clean water. Always read at the normal distance for vision. One should include diet components which have vitamin A. If particles of dust go into your eyes, wash your eyes with clean water. Do not look at the sun or a powerful light directly. If there is any problem, you should go to an eye specialist. Dear children, now let's learn about Braille system. The most popular resource for visually challenged person is Braille. It was developed by Louis Braille. Braille is a system of representing characters or English letters by raised dots. For example, here cat is written C-A-T. These characters are read by touching them with fingers. Dear children, now let's revise what we have.
Audiobook, Class 8. Sign reflected by it. You learnt in Class 7 that a polished idol. You can use a strip of the light is reflected in another direction. The light ray which strikes any surface is called the incident ray. The ray that comes back from the surface after reflection the same size as the object. 3. Did the image appear at same distance behind the mirrors as the object was in front of it? 4. Could it be obtained on a screen? Let us understand a little more about the formation of an image by a plane mirror in the following way. Activity 16.3. A source of light O is placed in front of a plane mirror PQ. Two rays OA and OC are incident on it, as shown in figure 16.5. Can you find out the direction of the reflected rays? Draw normals to the surface of the mirror PQ at the points A and C. Then draw the reflected rays at the points A and C. How would you draw these rays? Call the reflected rays AB and CD respectively. Extend them further. Do they meet? Extend them backwards. Do they meet now? If they meet, mark this point as I. For a viewer's eye at E, as shown in figure 16.5, do the reflected rays appear to come from the point I? Page 202. Figure 16.5. Image formation in a plane mirror. Since the reflected rays do not actually meet at I, but only appear to do so, we say that a virtual image of the point O is formed at I. As you have learnt already in class 7, such an image cannot be obtained on a screen. You may recall that in an image formed by a mirror, the left of the object appears on the right and the right appears on the left. This is known as lateral inversion. 16.3 Regular and diffused reflection. Activity 16.4. Imagine that parallel rays are incident on an irregular surface as shown in figure 16.6. Remember that the laws of reflection are valid at each point of the surface. Use these laws to construct reflected rays at various points. Are they parallel to one another? You will find that these rays are reflected in different directions, as shown in figure 16.7. Figure 16.6. Parallel rays incident on an irregular surface. Figure 16.7. Rays reflected from irregular surface. When all the parallel rays reflected from a rough or irregular surface are not parallel, the reflection is known as diffused or irregular reflection. Remember that the diffused reflection is not due to the failure of the laws of reflection. It is caused by the irregularities in the reflecting surface, like that of a cardboard. On the other hand, reflection from a smooth surface, like that of a mirror, is called regular reflection, as shown in figure 16.8. Images are formed by regular reflection. Figure 16.8. Regular reflection. Page 203. Do we see all objects due to reflected light? Nearly everything you see around is seen due to reflected light. Moon, for example, receives light from the sun and reflects it. That's how we see the moon. The objects which shine in the light of other objects are called illuminated objects. Can you name some other such objects? There are other objects which give their own light, such as the sun, fire, flame of a candle, and an electric lamp. Their light falls on our eyes. That is how we see them. The objects which emit their own light are known as luminous objects. Bujo says, I have a question. Can the reflected rays be further reflected if incident on another mirror? Let us find out. 16.4. Reflected light can be reflected again. Recall the last time you visited a hairdresser. She or he makes you sit in front of a mirror. After your haircut is complete, she or he holds a mirror behind you to show you how the hair has been cut, as shown in figure 16.9. Do you know how you could see the hair at the back of your head? In figure 16.9, we can see the hairdresser holding the mirror at the back of the head to show how the hair has been cut. Paheli recalls having constructed a periscope as an extended activity in class 6. The periscope makes use of two plane mirrors. Can you explain how reflection from the two mirrors enables you to see objects which are not visible directly? Periscopes are used in submarines, tanks, and also by soldiers in bunkers to see things outside. 16.5. Multiple images. You are aware that a plane mirror forms only a single image of an object. What happens if two plane mirrors are used in combination? Let us see. Page 204. Activity 16.5. Take two plane mirrors. Set them at right angles to each other with their edges touching, as shown in figure 16.10. To hinge them, you can use adhesive tape. Place a coin in between the mirrors. How many images of the coin do you see? Check figure 16.10. Figure 16.10. Images in plane mirror at right angle to each other. Now, hinge the mirrors using the adhesive tape at different angles, say 45 degree, 60 degree, 120 degree, 180 degree, etc. Place some object, say a candle, in between them. Note down the number of images of the object in each case. Finally, set the two mirrors parallel to each other. Find out how many images of a candle placed between them are formed. Check figure 16.11. Figure 16.11. Image in plane mirror parallel to each other. Can you now need to allow more light in the eye? The disappearance of the cross or the round mark show moving picture. Nature is bad for eyes. Insufficient light causes.
Students, now already we have discussed about the light, lesson light. Here this is only the audio which is going on. See what is the concept in this lesson. The first that we have learned about the image that is formed in the plane mirror, how the image is formed in the plane mirror. Then the that is the characteristics of the image formed in the plane mirror. Next is about the uh, reflection. Reflection are of two types: diffuse reflection and regular reflection. Now, wherever the images are formed, that means the surface is plane. That means the reflection is regular. If the surface is smooth, it is always the regular reflection that is formed. Wherever we see the images, तो हमें ये समझ में आ जाना चाहिए कि जो सरफेस है वो रेगुलर है, वो इरेगुलर नहीं है या डिफ्यूज नहीं है. जहाँ पर भी डिफ्यूज्ड सरफेस होता है वो इमेज फॉर्म नहीं करता है. Then the next is about the formation, that is the formation of the images, and that means the next thing, that is again we can say about the images, and next is reflection, multiple images. Okay, multiple images जो फॉर्म हो रहे हैं उसमें हमें सिर्फ ये करना है कि जो 360 means formula which is given, that day I have told you how to use it to find out the number of images that is formed when the two plane mirrors are kept in particular angle. तो जैसे जैसे एंगल difference between the two angle decreases, the number of images increases. Okay, so we can see here the multiple images they are formed, and this is nothing but the reflection of the reflected light. Okay, जितना जितना अंदर के अंदर रिफ्लेक्शन होगा उतना ही हमारा इमेजेस जो है वो फॉर्म होते रहेगा. So number of images we can get. So this concept is used for kaleidoscope. This concept is used in various purposes. Reflection जो पेरिस्कोप में भी हमने देखा था 6th क्लास में, है ना. That means if we can't see the image directly, we can see it indirectly. तो इस तरह से हम इसका यूज कर सकते हैं. Then the next thing is about the dispersion of light. ये आपके लिए थोड़ा सा डिफरेंट है. Dispersion of light में the white light gets dispersed or the spectrum is formed. जब ये स्पेक्ट्रम फॉर्म होता है तो ये व्हाइट लाइट डिवाइड होता है 7 कलर्स में. ये जो 7 कलर्स है, दिस 7 कलर is also called as a spectrum, and this is visible to us. This is visible light, the 7 colors into which the white light gets dispersed. तो ये हमारे लिए visible है, and it is always in the same series, that is the Vidgyor, जिसमें 7 colors होते हैं और इसका पैटर्न हमेशा ही सेम होता है. Now this dispersion can be also seen with the help of the Newton's disk. हम इसे how the all 7 colors are present in one color, that also we can give in the show in the experiment, as well as we can also show that how this one color can be dispersed into 7 colors. ये भी हम दिखा सकते हैं. तो प्रिज्म जो है, प्रिज्म को लेके अगर हम टॉर्च लेते हैं और डार्क रूम में टॉर्च को जब ये रे को अलाउ करते हैं टू फॉल ऑन द प्रिज्म, so the sunlight gets dispersed. The light, either it is the sunlight or the torch of the light, gets dispersed into the 7 colors. So this is nothing but the dispersion of the light. It is also called as spectrum. इसे कहते हैं spectrum. Understood? And the last, that is very important thing, the structure of your eyes. The structure of eyes में हमने देखा था, just I will explain you just for 2 minutes. Just wait, students. Here in this lesson, yes, so just I will show you the structure of eye. Okay, here now this one, just listen carefully. Just send you with the help of this arrow on the screen. This is the upper part that is called as cornea, which protects the eye. This one, the blue color structure inside, is the iris. Iris is attached with the muscular cilia. Okay, so it is attached, or we can say uh, here it helps to control or to manage the iris, because these iris helps uh, uh, the color, the light to pass. Okay, helps means it controls the light. जब कभी हम अगर हम अंधेरे में चले जाते हैं तो हमारी ये जो प्यूपिल है, पुतलियाँ जो है, वो बड़ी हो जाती है, so that it will allow the more entry of the light, so that we can see easily. और फिर जब हम बाहर निकलते हैं, डायरेक्टली सनरेज अगर हमारे आइज पे आ जाते हैं या ज़्यादा धूप होती है, तो ये जो आइरिस है वो कॉन्ट्रैक्ट हो जाता है. देन दिस विल अलाउ द क्वांटिटी ऑफ द लाइट टू पास. ये जो है छोटा सा जो होल होता है बीच में, दैट इज द प्यूपिल विच अलाउ द क्वांटिटी ऑफ द लाइट टू पास. नाउ हियर दिस इज द लेंस जिसके ऊपर ये पूरा लाइट गिरता है, और दिस इज द कॉन्वेक्स लेंस. कॉन्वेक्स लेंस में गिरने के बाद यहाँ पर उसका इमेज फॉर्म होता है ऑन द रेटिना. ये पार्ट जो है बैक साइड का, ऑपोजिट टू द opposite to the convex lens, that is the convex lens. और यहाँ पर ये इमेज फॉर्म होता है, that is called as retina, और उसको एक्सेप्ट करता है ये. these are the nerves these are the nerves which are attached to the nerve, that is the nerve which is attached to the brain. This is also called as the receptor. And now here this image which is formed on the retina is seen through this nerve, and it is the message is sent to the brain and the brain interprets it. ये इमेज यहाँ जो फॉर्म होती है रेटिना के ऊपर, दैट इज इन्वर्टेड. समझ में आ गया अभी? इट इज द रियल इमेज दैट इज फॉर्म्ड एंड इट इज इन्वर्टेड. यहाँ पर ये जो सेल्स है, नर्वस सेल्स, जो नर्व सेल्स जो है, वो दो टाइप के होते हैं, कोन्स एंड रॉड्स. ओके, दे आर cones and rods. You can see here they are cones and rods. Okay, so cones are responsible for the different types of colors or brightness. rods जो है, it is responsible for the darkness. तो हमारे में अगर कोन्स ज़्यादा है तो हमें अलग अलग कलर दिखाई देंगे, we can identify it. और कुछ एनिमल्स में सिर्फ रॉड्स होते हैं, that means they cannot identify the colors, they can only see in the night. We can see here due to the cones. We can see different colors. We can see in the day due to the cones. Okay, so this is the structure of our eye. Okay, understood, students? So tomorrow, if possible, I will explain you regarding this lesson, or if you have any doubt, we can further clarify the doubts, and then day after tomorrow, that means again then we will start with our revision. Okay, so two lessons I will take at a time, and the last day means the third day I will be taking all the 4 lessons. तो 3 दिन में हमारा हो जाएगा रिविजन. Is it okay to you, students? Is it okay? So tomorrow, if you have any doubt, you can ask regarding this lesson. Already I have sent the question answer. Okay, thank you, students.